This video is on an introduction to partial derivatives, just the very basics. To differentiate partial derivatives, we must know with respect to which variable. All other variables are constants. Whenever we do a partial derivative, we have to have a function of more than one variable. We haven't met that yet in this class, and honestly, we don't really need it very often at all. Usually we talk just in terms of those things conceptually, but let's say we have a function of x and y that satisfies this equation here. If we want to differentiate this with respect to x, then x is the variable and anything else is a constant. And so the way we write that is like that. We write this little d kind of with a little bit of panache here. This is a notation that's required for partial derivatives, and necessarily it has to be different from regular old derivatives with functions of one variable. So that indicates, oh, we have a function that is a function of several variables. Then, as it says here, all other variables are constants. So x is not a constant, so we need to differentiate it normally. So bring the power down, reduce the power by 1. Y is a constant. I'll go ahead and write it in there. Usually you don't do this, but that guy right there is a constant, and his derivative is 0. So what do we have next? Y is a constant, 2 is a constant, but x is in there. So isn't this going to simplify to be 4x, y? If it's 6y, that's just going to be 0, and then we're going to have 8. So that differentiates to that. Y is a constant. Y is a constant there. That differentiates to that. Your final answer here, if you want to leave the zeros off, would be 15x squared plus 4xy plus 8. If you took the same function and you differentiated it with respect to y, and you would write d with panache f, d with panache y, like that. Now we'd say, oh, okay, anything that's not a y is a constant. So x is a constant, and a constant multiplied by 5 is just another constant. So if we're showing our work here, when you differentiate that bit of it, you'll get 0. When you differentiate the next bit, you'll get 8y. When you differentiate the next bit, you'll get 2x squared, because y is to the first power, and so when you differentiate it, it goes to the 0 power, plus 6, so that gets differentiated to that, that gets differentiated to that, and 8x will get differentiated to 0. If you wanted your final answer, I think, wouldn't it be 8y plus 2x squared plus 6? That's how you do partial derivatives.